one of the most influential AI researchers in the world, saying he has effectively stopped typing code. So the obvious question is, if he's not typing code, what exactly is he doing? He's designing the systems that let agents do the work. And there's a discipline behind it that most engineers are missing. Mitchell Hashimoto, co-founder of HashiCorp, calls it harness engineering. And it is the biggest shift in how software gets built since we moved to the cloud. For the last 3 years, we have all been waiting for the models to get smarter. We thought the model was the bottleneck. But we've crossed a threshold. The models are now capable enough to do the work. The bottleneck is no longer the model. It is our ability to build a reliable system around it. If you just take a raw, highly capable model and point it at a codebase, it will fail. It gets stuck in doom loops, trying the same broken fix 10 times in a row. It suffers from false completion, telling you a feature is done without actually running the tests to prove it. And it causes architectural drift, making local fixes that violate your global design rules. A raw model is smart, but it is deeply unreliable. It is like giving your junior developer root access and no code review. This brings us to the core insight of this entire shift. An agent is not just a model. An agent equals a model plus a harness. The harness is the scaffolding that turns a capable but unreliable model into a reliable work engine. As the engineering team at LangChain put it recently, if you are not the model, you are the harness. So what actually is it? It is everything that surrounds the model. It is the execution environment, the isolated sandbox where the agent runs safely. It is the context layer, the maps and documentation the agent reads at startup so it knows where it is. It is the architectural constraints, the deterministic linters that block bad code before it merges. It is the orchestration logic, the workflow that tells the agent what to do next. And it is the verification layer, the system that forces the agent to test its own work before it claims to be finished. If you think this is theoretical, look at what the top teams are actually doing. OpenAI recently revealed they have built a production code base of over 1 million lines of code. Exactly 0 lines were written manually. A team of just 3 engineers over 5 months. 1,500 pull requests merged, agents running unattended around the clock. Those engineers did not write the code. They wrote the system that wrote the code. That system is the harness. Stripe is doing the exact same thing. They are currently merging over 1,300 pull requests every single week written entirely by their internal agents, which they call minions. These are fully unattended. A human engineer tags a bot in a Slack thread, walks away, and returns later to a finished, tested, and verified pull request. That is only possible because Stripe spent years building a world-class execution harness. We have just seen examples that indicate a significant shift is underway. The top experts like Karpathy, the top companies like OpenAI and Stripe, they are no longer writing code. They are designing systems that write it, reliably at scale. That is harness engineering, and that is where you want to be. So, how do you actually build an effective harness? In video 2, we open the hood. The 3 technical layers every harness needs: the execution environment, the context constraints, and the orchestration loops, and how Stripe, OpenAI, and LangChain built theirs. I'll see you there.